The Federal General Services Administration recently declared that in order for any major project to receive design funding from the GSA, spatial program building information models are required to be submitted with the proposals. The Wisconsin Division of State Facilities now also requires all major construction projects to begin with a BIM model, signaling the fact that individual state governments are following suit. A relatively new term within the construction arena, building information modeling is the process of generating and managing building data during its life cycle. It uses three-dimensional, real-time dynamic building models to increase productivity in building design and construction. A basic premise of BIM is a collaboration by architectural, MEP, and structural design teams at different phases of the project's life cycle to insert, extract, update, or modify information. BIM methodology creates a more efficiently executed construction project and serves as a reliable basis for ongoing decisions about the facility and its assets. This increased level of efficiency is a major reason why BIM is rapidly becoming a design standard, not only for government agencies, but for many leading engineering contractors and construction firms. D. Kramer, one of Michigan's leading HVAC firms, has already successfully integrated BIM into several construction projects they have coordinated throughout the state.
We involve all the mechanical, electrical, plumbing, piping contractors, an architect and engineer with their files into a building information model. Everyone produces their drawings. We insert them into software that can tell us where collisions are happening, and we coordinate those using that tool.
D. Kramer applied BIM as a method of integrated project delivery during a remodel of Hurley Medical Center in Flint, Michigan. Hurley is a 443-bed public, nonprofit teaching medical center that offers a wide variety of hospital health services. With over 76,000 emergency cases each year, Hurley decided it was more beneficial to separate their main emergency department from their pediatrics emergency department. D. Kramer partnered with 3D Imaging Services to assist in the preparation of their initial proposal to Hurley. 3D Imaging Services provided integrated as-built modeling and project visualization solutions to a multiple array of industries. For this particular project, 3D Imaging conducted exterior scans of the medical center's existing emergency wing. While many of its competitors would have to manually collect measurements gathered from tape measurers or laser rangefinders, 3D Imaging utilized a faster, safer, and more accurate tool, the Ferro Laser Scanner Photon. Matthew Bosley, 3D Imaging's Senior Managing Director, coordinated the planning and execution of the 4-day process.
The Ferro Scanner allows us to quickly and easily capture hundreds of thousands and millions of points of data compared to what we used to do with the traditional surveying techniques, which enable us to capture about 3 points a minute if we were lucky. And the portability of this unit is incredible. We can pick up, set up in a matter of just 5 minutes and do hundreds of locations a day, enabling us to do 1 billion points in a day.
Matthew and his team completed 276 scans of the exterior of Hurley in only 4 days without any interruption to the daily operations of the hospital. The 276 scans were then rendered together to form a 3D point cloud of the entire medical center campus. The point cloud was directly imported into AutoCAD for generation of line drawings and the 3D model that would be exported into Revit to form the full BIM model with all the necessary build details. Using traditional methods like laser lines and tape measurers would have taken a team 30 to 60 days. In addition, using a laser scanner enables data collection of hard-to-reach spaces and ensures that there are no measurements missed.
One of the big benefits of 3D scanning that I see for the construction industry is the old way of doing things was you'd take an existing building, you'd have to go out there with men and physically measure where things were located within the facility. Very time-consuming, very expensive to do that, to be accurate on the new work that you're trying to do. With 3D scanning, you can get to a building information model very quickly with high accuracy of the existing condition of the facility and go ahead with construction very efficiently.
Building information modeling is paving the way for greater collaboration among architecture, engineering, and construction firms throughout the life cycle of construction projects. As innovative companies like D. Kramer and 3D Imaging Services have already experienced, high-accuracy laser scanning will be a critical component for capturing the physical models at the level of speed and detail required.
In the next 5 to 7 years, D. Kramer is very excited about the possibilities of furthering their business in the building information modeling arena, as well as 3D scanning, and our past successes with 3D Imaging Services and Faro Scanning are proof that a change in the construction industry is on the way, and it's a good one.